We look at a problem from 2020 China math competition. It's a geometry problem where we have a circle here. We're given that A, B, C, D, E are on the circle such that the arc ABC and BCD and CDE all equal. We want to prove the marked angles here are congruent. As always for a geometry problem, you should try to prove it. Sometimes you have to struggle a little bit. This is how you learn. Alright, some background here is that for a circle, for the angles extended by the same segment, they are congruent. In our case, so BAD and BCD equal to each other. A very common used property in math competition, that is, if you have 4 points, A, B, C, D, if they are on the same circle, then alpha equal beta, which is the same thing, right? This is just the previous fact restated. However, the reason I want to put it here is because the converse is also true. That is, if you have A, B, C, D such that the angle extended by this equal to each other, then we claim that A, B, C, D must be concyclic. That is, the 4 points are on a circle. How do we prove that? We're going to skip the details, but the idea is that we're going to prove by contradiction. For example, we know that for any ABC, you can have a circle go through ABC. We want to prove that D is also on that circle. If not, D could be outside or could be inside. In both cases, you can prove by contradiction. I skip the details here. Now, with the hint that we have to use the property we just introduced, can you solve it? Pause the video again if you want to. Try it yourself. So we're given that this arc here equals this arc. They share a common segment here, so which means this part is going to equal this part. So similarly, we're saying that BCD arc equal CD, and CD here is common, so which means this BC and D, these two arcs are the same. In order to prove this angle here are congruent, so we need to use some properties we cited earlier. Now the trick to solve geometry problem is to be able to find out what additional line you can construct or make certain connections. What we do is extend CP so that it meets the circle at another point. Let's call it R, right? This point R. And we make another connection for the B and D. For this one, the 3 lines, right? So let's assume this angle is alpha, which means this must also be alpha, because they are the angle corresponding to the same segment here. Let's call this angle beta. This is corresponding to this segment here, right? This angle here, beta, right? Earlier we argued that this segment is the same as the DE, so which means the corresponding angle here must also be the same, which is beta. So we have beta here. Let's look at the angle here. Let's call it X. When you look at this triangle here, right, this triangle, this angle, exterior angle equals the sum of the other two, so which is X equal alpha plus beta. Now, when we look at this quadrilateral here, right, so we have exterior angle here equals this alpha plus beta. This is also alpha plus beta. So which means the 4 points are on the same circle. Okay, let's call this point T here, right? So we claim that A, T, P, R are concyclic. This is X is alpha plus beta. We can find another angle which is also alpha plus beta. The angle corresponding to this arc. The angle for this arc in this diagram is going to be this one, right? So this angle is also alpha plus beta. The angle ERQ. Alright? So this part is alpha plus beta. Right? Now, when you look at these 4 points, right? This angle here and equal this angle equal alpha plus beta. So they are also concyclic. So the new points, right? So here we mark it Q, E, R, and T. Yeah? So Q, E, R, and T also concyclic. Now we can prove that the angles are equal. Alright, by the first fact, we know that this angle here, right, must equal this angle here. By the second property, we're going to mark the points here, right? Second property here. Angle here, right, must equal the angle here, which is a common angle here, okay? By the way, this angle is not beta, okay? So here we have the proof. EAQ, right, is equal to the angle PRT. By the second property, we know that this angle is also equal to this part, right? Notice that beta is the bigger one. Okay, this is the intermediate angle. Okay, so that's equal to angle PEQ. Okay, so the angle PEQ here equals the intermediate angle equal the other angle. Okay, so that's the proof. For these and other interesting math problems, please like, share, and subscribe to the channel.